Ladies and gentlemen, good evening and welcome to another session of Nambani Academy, Grade 11 Physical Sciences, and we are currently busy with quantitative aspects of chemical change. We have done a lot when it comes to the topic itself. We are moving towards now the completion of the topic, and just remember that today also is our last day of our virtual camp. But if there's anything more that you need, kindly feel free to contact me privately and we can discuss further. With that being said, let me start with now Ratanang Pesho. How are you?
I'm good, and you, sir?
Very good, thank you very much. Nyakallo.
I'm good, thank you, sir.
Thank you very much, Your Excellency Neo.
I'm good, and how are you, sir?
I'm very good, thank you. Moteo CDT.
I'm good, sir.
Thank you very much. Lwandle Vezi.
I'm good, and yourself, sir?
Very good. Vonolo Matosa.
I'm fine, sir.
Thank you very much. Ba Anetse Mogeseng.
I'm good, sir. Thank you for asking.
Thank you very much. Katlego Maritz will not be joining us, as well as Lisedi. But now Lisedi said she will try to connect, so I believe everybody is here for today, unless if I'm missing somebody else. Ladies and gentlemen, Ba Anetse, kindly confirm, can you see the screen?
Yes, I can.
Thank you very much. Ladies and gentlemen, without wasting any time, let's get into it. Yesterday we spoke now about empirical formula in detail, as well as percentage composition. So we did examples of that and we explained the concepts in detail. We further moved now into examples of percentage composition themselves, where we tried now to explain the differences in terms of the key challenge that we had in terms of number of atoms and the molecular mass of the element. But that was now dealt with, done in detail. So it basically says we moved into the empirical formula, and in the empirical formula we explained all the steps. We did one problem, one example, and Lwandle asked me, say, can we now have a problem where we can work with the molecular formula? And I said, yes, we will have that, but the key thinking should be 1 up to 6, which is now the empirical formula. We must be very happy now with this particular one. So if we are happy with the empirical formula, it will be easy now to add the element of molecular formula. So that is basically what we are going to do today. So this was now an example or a problem that I gave you for determining the empirical formula. Very happy. It was done nice and in detail. So I have another one here. I'm going to quickly do this one together, but remember the emphasis will be now on 6.2. Why 6.2? Because it says determine the molecular formula of the acetic acid if we are given now 60 grams per mole. But before we get into that, we need now information that relates to 6.1. 6.1 says determine the empirical formula. So I'm going to make that table of ours CHO. And what do we know? We have the mass, number of moles, divide now by the smallest, divide by smallest, and then it will give us our ratio, and then we get now the ratio, and then it will give us the empirical formula. So this is 39.9, this is 6.7 grams, and then this is 53.4. So let's calculate the number of moles. Number of moles will be just 39.9 divided by 12, and then 6.7 divided by 1, and 53.4 divided by 16. Then we take a calculator. The calculator will be 39.9 divided by 12. This will give us something like 3.325 mole, and then this will give us 6.7 mole, and then 53.4 divided by 16 is equals to 3.3375 mole. Then which one is the smallest? Basically the one which is the smallest, it's this one, so we are going to divide everything by that. Then when we do that, we basically say fine is equals to 3.325 divided by 3.325, 6.7 divided by 3.33325, and 3.3375 divided by 3.3325, and then this will give us 1, this will give us 2, and that will give us 1. So our empirical formula is just now CH2O. Very happy with that. Now we can go to 6.2. When we go to 6.2, we said we are going to need our multiplier. Let's call this multiplier X. We said it will be the molecular mass of the compound divided now by molecular mass of the empirical formula. So what does this say now to me? It says I need to go back and calculate the molecular mass of the compound, but when I check that, it is now already given as 60. But I also need molecular mass of the empirical formula. Remember, there's a huge divide there. Let me do this and maybe add a line which is blue for the purpose of explaining that we have a huge division line there. Fine. Now it basically says I have the 60 that is given. I must now go and calculate the molecular mass of the empirical formula. The molecular mass of the empirical formula will be M of CH2O is equals to 12 plus 2 multiplied by 1 plus now 60. Then this is basically just 12 plus 2 plus 16 will give us 30 grams per mole. So when we go to our formula of the multiplier, we are going to have 60 divided by 30. This will just give us now 2. What does this mean? This means I'm going to multiply now everything in the empirical formula with 2, and that will give me C2H4O2, and this now will be my true formula of acetic acid. Ladies and gentlemen, you can ask your questions. Ratanang,
Sir, I don't have any questions.
thank you very much. Moteo CDD,
Sir, can you please explain where you got the 60 from again?
the 60 is, look at 6.2, determine the molecular formula of acetic acid if the molar mass of acetic acid is 60. So we are used to being spoiled, so I want to say this first part in most cases will be given. In most cases, I want to believe so.
Okay, thank you, sir.
Thank you very much, Moteo. Lwandle, are you happy?
Yes, sir.
Thank you very much. Then basically that is how you go about using now the multiplier for you to actually get the correct formula for the compound that is now given. So what is critical is making sure that you get your empirical formula to be correct. If your empirical formula is correct, then it means you are going to also get the correct molar mass of the empirical formula. Then divide the molecular mass of the formula, of the compound given with that 30. It will give you the multiplier. Just check the multiplier multiplies basically the subscripts. It multiplies now the subscripts, which is 1, 2, 1. So 2 multiplied by 1 is this 2, 2 multiplied by 2 is this 4, and then 2 multiplied by 1 is that 2 there. So be on the lookout that you actually multiply the subscripts, not the entire formulae that is given. Thank you very much. If there are no questions, let me give you your 30 seconds for you to digest, and immediately after that we'll look into the limiting reagent. Thank you very much, ladies and gentlemen. Let's go now to the limiting reactant. The very first thing that we need to know about the limiting reactant is the definition. Definition of limiting reactant. And the word says it all, limiting. So it is defined as a reactant that is used up first in the reaction. It is used up first. Other books or definitions that you can come across is defined as a reactant that completely reacts first in the reaction, and this will now be your easy 2 marks. Now somebody asked me, how best can I assist learners to identify this limiting reactant? There are many ways of doing it, but there's one way that I personally been using over the years, and it has given me the right approach. Why, ladies and gentlemen? Because if you are unable to identify a limiting reactant, you are going to get everything wrong. Why? Because the limiting reactant is the one that limits the actual outcome, the actual measure of the products that we have. We remember when we started quantitative aspects, we said we are interested in the measure of substance, which will either be the quantity of the substance. So if the limiting reactant is complete, is used up, it basically says it is limiting the end products. So whenever you are going to perform a calculation that includes a limiting reactant, ladies and gentlemen, it will be key and important for you to identify the correct one. So for purpose of explanation, I have selected this question here. It says aluminium reacts with O2, and then the balanced chemical equation is given. 3 moles of aluminium and 2 moles of oxygen are placed into a reaction chamber and allowed to react. Which substance is the limited reactant? Ladies and gentlemen, this is what I'm going to do. We are given the number of moles. Fine. Now we are going to say, let's develop a general formula. The general formula will be N of reactant A over N of reactant B. This will be now A, which is the coefficient of A, over B, which will be now the coefficient of B. But where do we get this, ladies and gentlemen? We get this basically from the molar ratio. So whatever I do, I must get now the number of moles of A and the number of moles of B. But in this instance, I'm going to say I want sorry, let me maybe write 4 aluminium plus 3 O2 gives us 2 aluminium 2 O3. What I want to do is I want to emphasize that I am going to take aluminium as A, I am going to take oxygen as B for the purpose of explanation and understanding. Once the foundation is solid, then I will be very happy. Can you see also that we have the coefficients there? Then the coefficients will also be part of this. Step number 2. Let's say this is 1. Step number 2 is choose one reactant to be unknown. You choose yourself one reactant to be an unknown. 3. Compare the final answer with the initial number of moles. Initial number of moles. 4 obviously will be identify the limiting reactant. Remember, I usually say the best way of doing these things is actually for one to have a system or an approach that one can use. Sorry. Yes. Now, let's get into it. So I am going to say, let me put it in a box so that it can stand out. Then I'm going to say I choose N aluminium over N of oxygen. The mole ratio will be now 4/3. That is where now I start. But the second step says choose one reactant to be unknown. So what is it that I'm going to do? I am going to choose oxygen as an unknown. So I'm going to replace now aluminium. I am given the initial moles as 3. 3 divided by NO2. So I chose that I am making oxygen to be my unknown. So I am not going to use these 2 moles of oxygen that was given to me. Is equals to 4/3. What do we normally do? After having the molar ratio, we cross now multiply. Then I'm going to have 4 N of O2 is equals to 3 multiplied by 3 is 9, ladies and gentlemen. Divide by 4, divide by 4, then N of O2 is equals to 9 divided by 4 is something like 2,25 mole. I hope we are still following. Now, ladies and gentlemen, this is where the tricky part comes in. I have this number of moles of oxygen, which is 2,25. So basically, what does this mean? Basically here, this is the number of moles needed for this reaction to take place. But when I check, I am only given 2 moles, but I need 2,25 moles for this reaction to be complete. So hence bullet number 3 will say compare the final answer with the initial number of moles. So I know that I needed O2 needed is greater than N of O2 actual. So what does this mean? It means I do not have enough oxygen for this reaction. So it means now O2 is a limiting reactant. Questions, please. Lwandle?
Yes, sir. I'm a little bit lost, sir. I lost, sir, when we are at now the 3 over n of O2. I understand the 4 over 3, but I'm not sure where sir got the 3 because I want to think that it's the 3 mole of aluminium, but then I do I don't think I don't know how to explain to sir, but I understand everything from like I understand what sir did, but I don't know where sir got that 3.
This 3 at the top, which is the numerator, it is the 3 from the statement. Aluminium reacts with O2. The balanced equation is given. 3 mole of aluminium and 2 mole of O2 are placed in the reaction chamber. So the 3, this one here, comes from given information. Given information. Kindly
So sir,
yes.
I just want to so we got that 4 over 3 from the coefficients in the formula, and then our next step is we take from the given information when we choose one to be unknown.
100%. But remember, they can either give it to you as mass, then it means you must calculate the number of moles. We can only compare in terms of mole ratio only if you are working with the number of moles.
Oh, so sir, the first one is the more. Okay, no, I see. Okay. Thank you, sir.
Thank you very much. Ratanang?
Sir, is the limiting reagent always smaller than the answer that you get?
Yeah, no. Let's say bigger. Because check here. The one that we calculate is basically the one that we need, ne? But the one that we have is the actual. So if the needed is bigger than the actual, it means that must be our limiting reactant. I'm not sure if I make sense. So the when we use the molar ratio, we actually calculate the number of moles that reacted. So we are the ones that we need. So in this instance, we only have 2, but we need 2,25. Follow up question, Ratanang?
No, sir, I understand.
You understand?
Yes, sir.
I'm going to do it without choosing oxygen as an unknown, and let's choose aluminium and see if it will also make sense, because there's so many ways of interpreting which one is a limiting reactant. But in this case, we start by saying the one that we need is actually greater than the number of moles of what we have. CDT inputs, please.
I'm all good, sir.
Thank you very much. Your Excellency, Mr. Nyoko.
I'm still good, sir.
Thank you very much. Ladies and gentlemen, let's try it again. Let me delete this. Let's try it again for making aluminium, in this case, to be a limiting reactant. Not to be a limiting reactant, but to be an unknown. Let's see if it will work out nicely. I'm going to write it in pink. Let's see. We start by saying N of aluminium over N of oxygen. We are happy with that. Now this is 4 over 3. Very happy also. Now I am this learner who decides to choose that aluminium must be my unknown, then what will be the number of moles of oxygen from the given information? It must be 2 equals to 4 divided by 3. What do we do then? Cross multiply. Then we have 3 n of Al is equals to 2 multiplied by 4, which is 8. 3n of aluminium divided by 3 divided by 3, they cancel each other, and n of aluminium is equals to 8 divided by 3 is equals to 2,67 mole. So now what does this mean? This means n of aluminium needed is actually smaller than n of aluminium actual. Why, ladies and gentlemen? Because we calculated that we need 2,67, but we have now a total of 3 moles. So what does this mean? It means I have more than enough of aluminium, because the actual that I have is 3, but I only need now 2,67. So what can I say about aluminium? I can easily say with aluminium is in excess. There's more than enough. Then what does this mean? O2 is now a limiting reactant. Ba anetse inputs, please.
So no input, I'm still fine. I understand.
You understand. Thank you very much.
Yes, sir.
Bonolo Mathosa.
Fine, sir, so far.
Neo Mudiana.
I'm still fine, thank you, sir.
Thank you very much. Ratanang Pesho.
Sir, I'm still a bit confused, sir. So, if there is excess, if it is in excess, sir, does it mean that it's not a limiting reagent?
Yes, it means it is not a limiting reactant. Why? Because for one to be a limiting reactant, it means the actual amount of moles we have, it's less than what we need. So in this case, the ones that we need for aluminium are smaller. We need 2,67, but we have a total of 3. So now it will be 3 is greater than 2,67. So this actual that we have tells us that aluminium, it is actually in excess. We have more than enough of aluminium.
Okay, so basically, I'm going back to oxygen now. Oxygen, the actual was bigger than the needed, right?
Let's go to it quickly. It's this one. Can you see it on your screen?
Oh, never mind. The needed was bigger than the actual. Okay, so I understand now.
Yes. So it means if I need more but I have less,
okay, so
then that actual one becomes our limiting reactant. So it's either you check by identifying, but you at the beginning you don't know. Like in this instance, I made now oxygen to be my unknown. I did not know the answer thereof, that oxygen is actually a limiting reactant. What informed me that it is a limiting reactant, it's now calculating what I need against what I have. So what I need is basically more than the actual that I have, then it becomes now a limiting reactant. Hence, I thought let's do it for a learner who decides to say, I am going to make now aluminium and unknown. So this learner will find that, but I have more than enough of aluminium. So aluminium cannot be a limiting reactant. It is in excess. Therefore, oxygen becomes my limiting reactant. Happy.
Okay, sir.
Thank you
Yes,
very
sir.
much. Luandle,
No, sir, I'm fine now. Thank you.
thank you very much. Bunolo Matosa,
I'm fine, sir.
thank you very much. Ladies and gentlemen, with that explained, let's try now and do this. Just do A for me, please. Don't do B, C, just A. Because now, if we are unable to identify the correct limiting reactant, then B and C is going to be a problem for all of us. So the best thing to do is just to identify a limiting reactant. So I'm going to give you 10 minutes for you to perform this. 10 minutes is quite a lot. Let's make it just 7 minutes. Hatanan, your hand is up. Is it an old hand?
Oh, so let me take it down.
Thank you very much. Just identify the limiting reactant for me. I'm just waiting for one answer, ladies and gentlemen, then we can get straight into it. Kindly send so that we can easily see and check where we are in terms of identifying a limiting reactant. Thank you very much. Received. Let's check, ladies and gentlemen. Thank you very much for all your efforts. The first thing will be we are given mass. So the first step will be to convert the mass to the number of moles, and that was done exceptionally well. Thank you very much. So the number of moles of CO is just m over molar mass, which is 356 divided now by 12 plus 16 is equals to this number of moles. Then n of H2 is equals to m over molar mass. This is now 65 divided by 2 multiplied by 1. Then it will give us this mole. So let's quickly check. It is 356 divided by 12 plus 16. This will give us 12,71 mole. 65 divided by 2, 32,5 mole. So what are these moles actually? These are the actual moles I have. Actual moles. So step number 2, I am going to choose now CO as my unknown. The coefficient there is 1 and 2, so 1 over 2. Cross multiply 2 and CO is just equals to 1 multiplied by the number of moles of oxygen, which is 32,5. Then 2 NOCO is equals to 32,5. Divide by 2, divide by 2, they cancel. Then N of CO needed, let me maybe emphasize, is equals to divided by 2 is equals to 60,25 mole. Now, ladies and gentlemen, we must conclude. How do we conclude? We conclude by saying N of CO needed is greater than N of CO actual. Therefore, what does this mean? It means I have less than what I need. I need 16,25, but I only have 12,71. Therefore, it means CO is a limiting reactant. Ratanan Fehlo, inputs please.
Sir, I don't know what I did, but yeah, I got it wrong, but I understand what you said and wrote, but I wrote something completely different. So
Moteo, thank you, Ratanan.
Wait, I think. Okay, I think I understand where I went wrong. Yeah.
Okay. Okay. Where did you go wrong? Maybe I should ask that.
I accidentally typed in the wrong numbers in my calculator, hence why I got the number of moles wrong for CO, which I think, and also by the part where we were supposed to, cross multiply. I'm not sure if we were supposed to, like, I wasn't sure if we were supposed to do it like from like the arrows were supposed to face down or up, but I think they were supposed to face up, hence why. Yeah. Wait, no. I actually, no, wait. I used, okay, so I got the thingy right. Sorry, my bad. But the thing is, I used H2 rather get the what again the limiting at reactants. So
Okay. Thank you very much. Let's try and do it for a learner who decides to work with H2 as an unknown. I'm just going to try and squeeze it here for the purpose of explanation. It will be n of CO over n of H2. This is still 1 over 2. Then we have 12,71 over n of H2, which is equals to 1 over 2. Then we cross multiply. We have n of H2, which is equals to 2 multiplied by 12,71. Then n of H2 is equals to 12,71 multiplied by 2. This is now 25,42 mole. So what does this mean? It means n of H2 needed, ladies and gentlemen, it's smaller than n of H2 actual. Can you see that? So it means now we have 32.5 mole of hydrogen gas, but we only need 25,4. So it means there's going to be surplus, or there's going to be an extra number of moles. So therefore H2 is in excess, and then CO is a limiting reactant. Questions, please. Let's start with Your Excellency, Mr. Nyokong.
Sir, it's like I'm a bit lost and I'm trying to find a reason why I'm so lost. It's gonna take a while before I can find a question, sir.
Okay. Fully understood. And reflections of the day?
Nah, today was good, sir. Yeah, we learned something new.
And a little bit complex.
Very complex, sir.
Yeah, no. Neo, reflections of the day and inputs if you have any.
Sir, I learned a lot. I got some clarity on finding the limiting reactant, sir, and I am fine with it. Thank you.
Thank you very much. Luandle, reflections of the day and inputs.
So it was a very good lesson. I also agreed it was very complex. I don't know why it was so hard for me to grab the concept, but I think I'm getting there, and I think with more practice it'll become easier, because first steps make it like easy for me to try and like follow what's going on.
Thank you very much. Ba Anetse Mokgeseng.
So, like everybody else, today's lesson was pretty complicated, and I think it helped me identify my weak spots. So I think I'm gonna work on that from now.
Thank you very
Thank you so.
much. Bonolo Matosa.
Just one question, sir. You see, for the formula, sir,
Hmm.
does it matter whether you put the first reactant on the top and then as the numerator and the second reactant at the bottom as the denominator, or can you swap them and you'll still get the same results?
You can swap them, you'll still get the same results, but just ensure that when you swap them, you also ensure that you swap now your coefficients. So the coefficient or the mole ratio must correspond with the number of moles of the substance that you are referring to. That is very, very important. So hence I said there isn't a standard way of doing it. You are going to be exposed to so many different ways, but for me, I always try to have a certain sequence that I can use in order for me to have a proper understanding. And this question was only chosen for you to actually see that in essence limiting reactant is a very, very important concept. So I'm going to stop it here for today, such that you can go and digest what is a limiting reactant, as well as now be confident in terms of identifying one, because BC, ladies and gentlemen, are influenced by the limiting reactant. I have another question here also, which I'm going to give to you as a homework activity. But still, if our limiting reactant is not the correct one, B and C will not now assist us. I have also another one here, determine limiting reactant. So if the limiting reactant is not correct, then we cannot perform B. That is the reason why my emphasis for today will be: here is a concept of limiting reactant, have it with you, try and practice, follow the steps, such that you are now at a level of high confidence, to a point of you will be able now to do this one. I will give it to you as a homework activity when I send the e-notes, and this one also. And then maybe I should just say the last thing should be Ratanang. Overall inputs from Monday to Friday for to Thursday for our virtual camp, because this is the last day of the camp, and then we can wrap it off. Inputs, please, from Monday to Thursday.
So I really enjoyed these lessons. I think they gave me like a head start from for when we have to start doing this topic at school. And yeah, sir, thank you.
Thank you very much. So, like I said, it is taking about 3 weeks at school. So, we tried now to do everything in a week. But obviously, once we continue with our normal lessons, that will be easy now for us to solidify the easy information that is here. So, the key thing was to give you a head start. Spot on, ladies and gentlemen, from me to you, thank you very much. Let's meet now very soon. I'm just trying now to see when and how will we be able to resume our classes, but it should be very soon. So the homework that I'm going to give, the due date is tomorrow before 6 o'clock. Thank you very much and have a lovely holidays.
Have a nice
Thank you.
evening, so
You
bye.
too, sir.
Okay. Thank you, sir. Bye.